Hello everyone. Let us see the solutions for Kerala Public Service Commission Lecture in Electronics Engineering 2021 question paper solutions part 1. First question. If limit extends to 2 x power n 2 power n x power n minus 2 power n by x square minus 4 is equal to 20, then n is a positive integer. They ask to calculate the value of n. So given expression is limit extends to 2 x power n minus 2 power n by x square minus 4 is equal to 20. Substitute n is equal to 2 directly. On substitution, it will result 0 by 0. So this which is an indeterminate form. So if 0 by 0 exists in limits, then it is an indeterminate form. Apply L Hospital rule, that is limit extends to 2. So x power differentiation in numerator and differentiation in denominator separately. D by dx of x power n is n into x power n minus 1. So n into x power n minus 1. So d by dx of any constant, is 0. So differentiation of 2 power n is 0 by x square. Differentiation of x square is 2x minus 0. That is equal to 20. Now substitute limit value x is equal to 2. N into 2 power n minus 1 by 4 is equal to 20. That is n into 2 power n minus 1 is 80. Keep n is equal to 5. So 5 into 2 power 4. So 2 power 4 is 16. 5 into 16, that is equal to 80. The equation is satisfied. For n is equal to 5, this above expression is satisfied. LHS is equal to RHS. So the correct answer is B. Next question. The slope of normal to the curve y is equal to 2x cube at a point whose x coordinate is 2. Given curve is y is equal to 2x cube. The slope of the curve or slope of tangent is dy by dx. It results in slope of the curve or slope of tangent. So d by dx of y is 2x cube. So that is 2 is constant. D by dx of x cube is 3 into x square, 6x square. Slope of tangent at x is equal to 2. Dy by dx at x is equal to 2. Its value is 6 into 2 square, that is 24. Now we know that the slope of normal is perpendicular to the tangent and slope of normal is minus 1 by slope of tangent. Normal is perpendicular to the tangent and its slope is, that is slope of normal is minus 1 by reciprocal of slope of tangent. So that is, now slope of normal is equal to minus 1 by slope of tangent, that is 24. Minus 1 by 24 is the correct option. So there is one rule from this: slope of normal into slope of tangent is equal to minus 1. Slope of normal into slope of tangent is equal to minus 1. Also apply this here. Slope of tangent is minus 124 and slope of normal is minus 1 by 24. Correct option is B. Next question. The value of integral x minus 1 by x square into e power x dx is. So this is a given integral. So for this given integral, let us, so x by x square, that is 1 by x minus 1 by x square e power x dx. It can be written as 1 by x e power x minus 1 by x square e power x into dx. So this is the integral. Let us keep, let f of x is equal to 1 by x. Then f dash x, derivative of f of x is minus 1 by x square. Now it will be same as e power x f of x plus e power x, so that is 1 by x e power x dx plus minus 1 by x square e power x dx. So this is f of x e power x dx plus f dash x e power x dx. So from this formula, its value is e power x f of x plus c. Now f of x is 1 by x, that is e power x into 1 by x plus c is the answer. So the correct option is D, e power x into 1 by x plus c is the value of integral. Next question, e power x integral e power x 1 plus x by secant x e power x. This is a given integral. We need to calculate the value of this given integral. So we know that in integration, integral cos x is sin x and integral sin x is minus cos x. Put To solve this integral, put x into e power x is t. So differentiation, so x into e power x plus e power x into 1 is equal to into dx is equal to dt. Now x into e power x, so this complete term, this complete numerator is replaced with dt by secant t. So 1 by secant x is 1 by secant theta is cos theta. So now it will become integral cos t dt. So integral cos is sin x, that is sin t plus c. So sin, substitute t is x into e power x. Sin of x e power x is a solution. Sin of x e power x is a answer. Sin t plus c, that is sin x into e power x. So option A is correct. Next question, question number 5. The integrating factor of differential equation dy by dx minus y by x is equal to sin x. The first order differential equation is given as dy by dx plus p of x into y is equal to q of x. This is the expression for first order differential equation. So from this, p of x and q of x are the p and q, p of x and q of x are the functions of x. Then integrating factor is, so integrating factor is, it is written as for this differential equation, integrating factor is e power integral p of x into dx. So general solution is integrating factor into y is equal to integral of integrating factor q of x into dx. So this is a general solution for the given differential equation and integrating factor for the given differential equation. Now in the question they have asked integrating factor only. So for this, the above expression can be rewritten as like this, which is a linear differential equation. Here p of x is minus 1 by x and q of x is minus 1 by x and q of x is sin x. Integrating factor is equal to e power integral p of x into dx. So that is e power integral minus 1 by x dx. So integral 1 by x dx is, we know its value is log x. So that is e power log x base e. So now it will become x e power minus log x minus of log e base e. So its value is x power minus 1 plus x power minus 1, that is equal to 1 by x. So the integrating factor for the given differential equation is 1 by x. Question number 6. A matrix has matrix X. The number of rows in matrix X is A plus B and number of columns is B minus 1. This is related to matrix X. Similarly, the order of matrix Y. So that is, it has matrix Y has A minus 2 A minus 2 rows and A plus 2 columns. Given the matrix xy exists, also the matrix yx exists. So if a matrix multiplication is product exist, means the number of columns in first matrix is equal to number of rows in the second matrix. Number of columns in matrix x is equal to number of rows in the matrix y. So that is, number of columns in xy, number of columns is b minus 1 is equal to number of rows a minus 2. So this is equation 1. Similarly, in the question they have given matrix yx exists. That is, number of columns in y is equal to number of rows in x. Number of columns in y is a plus 2. Number of rows in x is a plus b. So from here, a get cancelled, b value is 2. Substitute b is equal to 2 here. 2 minus 1 is equal to a minus 2. Now it will result. So here it is b plus 1. It is b plus 1. 2 plus 1 is equal to a minus 2. It will result a value is 5. Therefore, a is equal to 5 and b is equal to 2. So correct option is 1. A is equal to 5 and b is equal to 2. Next question. The value of determinant. So this is the formula to calculate the value of determinant, and if determinant is 0. So generally for any matrix, if determinant is 0, then it is said to be a singular matrix. Given singular matrix, we need to calculate the value of k. So using this expression, value of k is 1 into 2 into 4 minus 5 into 2 minus 2 into 4 into 3 minus 5 into k plus 3 into 2 into 3 minus 2 into k is equal to 0. So that is 8 minus 10 minus 2 into 8 minus 5, 12 minus 5k, 12 minus 5k plus 3 into 6 minus 2k is equal to 0. Now on substitution, 4k is equal to 8 and the value of k is 2. The value of the determinant is 2. Next question. If C0, C1, C2, Cn denote the coefficients in the polynomial expression of 1 plus x whole power n, then sum of squares of coefficient is. In the question they have asked sum of squares of coefficients. So that is 1 plus x whole power n is 1 plus nx. The expression for 1 plus x whole power n is 1 plus nx plus n into n minus 1 by 2 into 2 factorial into x square, n into n minus 1, n minus 2 by 3 factorial into x cube, and so on. Similarly, for the expression x plus 1 whole power n is nc naught x power n plus nc1 x power n minus 1, nc2 x power n minus 2, and so on, ncn x power 0. Now multiply this equation 1, let it be equation 1, and it will be equation 2. Multiply these two equations, 1 plus x whole power n plus x plus 1 whole power n, it will result nc naught square, nc1 square plus nc2 square, and so on, nc n minus 2 square, nc n minus 1 square plus ncn square. So it is 2ncn that is equal to 2n factorial by n factorial whole square. 2n factorial by n factorial whole square. The correct option is A. Or this is a one more method to calculate the expression. So x plus n whole power n 1 plus x 1 plus x whole power n x plus 1 whole power n, multiply the two coefficients and equating the term x power n on both sides, then we will get the final expression. The sum of squares of coefficient for the given expression is 2n factorial by n plus 1 n factorial whole square. So correct option is A. Next question. Given 2 tan inverse 1 plus tan inverse 2 plus tan inverse 3 expression is, we know that tan inverse 1 plus tan inverse 2 plus tan inverse 3 is pi. So the value of this expression is pi, and the formula for 2 tan inverse x is 2 tan inverse x is tan inverse 2x by 1 minus x square, that is tan inverse my r and one more formula, one more expression, tan inverse minus 1 is minus pi by 4. Similarly, to calculate this tan inverse x plus tan inverse y, it is pi plus tan inverse x plus y by 1 minus xy if xy greater than 1 and x greater than 0, y greater than 0. In the question they have given x is greater than 0. So take this 2 tan inverse 1. So 2 tan inverse 1 is tan inverse, using this formula, tan inverse 2 into 1 by 1 minus 1 square. So that is tan inverse infinity. Tan inverse infinity is pi by 2. Tan inverse infinity is pi by 2 plus tan inverse 2 plus tan inverse 3. Here x is equal, let us assume x is equal to 2 and y is equal to 3. So x greater than 0, y greater than 0, xy is greater than 1. So we need to use this formula. So plus pi plus tan inverse x plus y, that is 2 into 3, 1 minus 2 in 2 plus 3 by 1 minus 2 into 3. So 1 minus 2 in this, its value is pi by 2 plus pi plus tan inverse minus 1. So tan inverse minus 1 is pi by 4. Pi by 2 plus pi minus pi by 4. So its value is 5 pi by 4. 5 pi by 4. So there is no correct option, but the value of tan in third quadrant, tan pi by 4 is equal to tan pi by 4. So the relevant answer is B. There is one more method. So we know that tan inverse 1, in the question they have given 2 tan inverse 1 plus tan inverse 2 plus tan inverse 3. So it can be written as tan inverse 1 plus tan inverse 1 plus tan inverse 2 plus tan inverse 3. So its value is pi. Tan inverse 1 plus tan inverse 2 plus tan inverse 3 value is pi. So tan inverse 1 plus pi. So tan inverse 1 is pi by 4 plus pi. So that is 5 pi by 4. So tan is positive in third quadrant. The value of tan 5 pi by 4 is equal, same as tan pi by 4. So we can choose the answer as pi by 4, but the correct answer, exact answer is 5 pi by 4. Next question. The foot of perpendicular from 2 comma 3 to the line 2x plus y minus 3 is equal to 0 is. So to calculate the foot, to find out the foot of the perpendicular, the procedure is find the slope of a given line. This is step 1. And find the equation of a line passing through given point and perpendicular to the given line. So perpendicular means the slope of perpendicular slope is minus 1 by slope of tangent. Next thought, in step 3, find the point of intersection of the two lines, which is the foot of the perpendicular. Okay, let us see our question. Given line is 2x plus y minus 3 is equal to 0. So we can arrange it as y is equal to minus 2x plus 3. So compare this line with y is equal to mx plus c. So the slope now is minus 2. Slope of line, this is a given line slope. Now slope of line perpendicular to the given line is negative reciprocal of slope of given line. So that is, so minus of 1 by m. So m is minus 2. So it will value become 1 by 2. Now slope of perpendicular line is m is equal to 1 by 2. Let x be a let x comma y be a point on this line. The equation of line passing through 2 comma 3 and perpendicular to 2x plus y minus 3 is equal to 0. It is given as y minus y1. So y1 is 3 is equal to m into slope is 1 by 2 x minus x1. So x minus x1. x1 is 0.2. This is the equation of line. Now it will become y is equal to 1 by 2x plus 2. Now we need to calculate the point of intersection of these two lines. So first line is, this is line 1 and this is line 2. Point of intersection of these two lines, y is equal to minus 2x plus 3 and y is equal to 1 by 2x plus 2. On solving, the value of x is 2 by 5 and the value of y is 11 by 5. Therefore, foot of perpendicular from 2 comma 3 to a line 2x plus y minus 3 is 2 by 5 comma 11 by 5. 2 by 5 comma 11 by 5. The correct option is D. Next, next question. Which among the following is a correct method for designing a combined footing for two column loads? In the design of combined footing for two column loads, the center of gravity of two column load, center of gravity, not the center of gravity of two column load must be practically as possible as coincide with the center of area of the base. See option 1, the center of gravity of soil reaction comes exactly in the middle of the column loads. So it may come or may not come in the middle. For some cases it may come, but some cases it doesn't come. The center of gravity of two column load coincides with the point of half of length of the footing. So this statement is also wrong. Next, the center of gravity of two column loads coincides with the point of intersection of diagonals of plan of footing. This statement is also wrong. So the center of gravity of two column loads coincides with the center of gravity of soil reaction. Center of gravity of soil reaction. Center of gravity of two column loads coincides with the center of gravity of soil reaction. So this statement is correct. Correct method for designing the combined footing of two column loads is the center of gravity of two column loads coincides with the center of gravity of soil reaction. Next question. If using a dumpy level and a level shifted staff and backside is noted on a back bench of reducer level 100 as 0.6 and foresight is noted as point A as 0.8. What is the reducer level at point A? So this dumpy level is the name of instrument and leveling staff is nothing but a foldable long scale for tracking for taking the reading. Now reducer level is given as, generally in normal cases this reducer level is given as benchmark plus backside reading minus foresight reading. Here benchmark is 100 and backside reading is 0.6. 0.6 is a backside reading and foresight reading it is mentioned as 0.8. So on calculation its value is 99.80. So correct option is B. Next question. What is fine aggregate? So in construction industry, aggregate in construction industry is classified into two categories. One that is coarse aggregate as well as fine aggregate. So coarse aggregate means aggregate retained in 4.75 mm sieve is termed as coarse aggregate, and aggregate passing through 4.75 mm sieve and retained by 150 micrometer or 0.15 mm sieve is termed as fine aggregate. An aggregate is said to be fine aggregate if it is completely retained by 0.15 mm IS sieve. So IS represents Indian Standard C. The correct option is B. Correct option is B. Next question. What is the yield strength of plain bars? Mild steel containing conforming to IS 432. So Indian standard 432. So the mild steel bars are known as FE 250 because this steel yield strength is 250 Newton per millimeter square, or it can also be termed as 250 MPa. This yield strength of plain bars can vary depending on the grade of steel and specification used. Correct option is A. In chain triangulation, what is the longest main survey line? In chain triangulation, the longest of main survey line is baseline. The longest of main survey line is baseline. The smallest of main survey line is tie line, and check lines are measured in the field during the survey process of land. In surveying and mapping, baseline is the main reference line, and checkline or proof line is used to confirm the accuracy, and tie line joins the fixed points on main survey line. So the correct option is D, baseline. Longest of main survey lines is D, baseline. So see some more points related to this. Baseline is the longest survey line that runs through the middle of the area to be surveyed. So this line is a baseline. It is a check line, and these are the tie lines. So tie line is line joining some fixed points as tie section on the main survey line. It helps showing the details of surveyed field. Some example diagram is given related to baseline, tie line, and check lines. Here the correct option is D. Next question. Compared to four-stroke engine of same size and RPM, this two-stroke engine practically produces. So two-stroke engine twice can produce twice as much power as four-stroke engine of same speed and size, but practically it is less than the twice and greater than the same amount of power produced by the four-stroke engine. Next, n- note point is for same rated power and same engine speed, a two-stroke engine and four-stroke engine, heavier flywheel is required in four-stroke engine. This heavier flywheel is required in four-stroke engine. So two-stroke engine is an engine that completes a power cycle with two strokes of the piston during only one crankshaft revolution. Similarly, four-stroke is an internal combustion engine in which piston completes four separate strokes while turning the crankshaft. These are definitions for two-stroke and four-stroke engines. When compared to two-stroke engine, it can produce less than twice and greater than the same amount of power produced by the four-stroke engine. This is a practical case. So ideal case it is twice. Next question. Flywheel is used. Flywheel is an mechanical device that can reduce power fluctuations in a system by storing excess rotational energy and releasing it when it is needed. So correct option is B. So to decrease the power fluctuations in the system. So some more points related to flywheel. So flywheel is a heavy wheel or a disc that rotates at high speeds. It absorbs energy so that means its speed is increased. When it releases energy, its speed decreases. Hence, from these 2 points, hence flywheel does not maintain constant speed. It simply reduces the fluctuation of speed. So flywheel acts as a reservoir of energy, balance the engine, and smooth out the power delivery. Flywheel stores energy in the form of kinetic energy. So flywheel is a heavy wheel or a disc that rotates at high speed. When energy is absorbed, flywheel speed increases. When energy is released, its flywheel speed decreases. That means flywheel does not maintain constant speed. It is nothing but a reservoir of energy, and it stores energy in the form of kinetic. It stores in the form of kinetic energy. So correct option is B. Next question. The function of clutch can be improved by. So clutch linings are friction materials that are used in clutches to transfer the power between engine and wheels. Clutch lining is made up of high friction materials. So high friction materials means and fits between pressure plate and flywheel. So high coefficient of friction means the surface is less slippery and has better grip. High coefficient of better coefficient of friction or high coefficient of friction means the surface is less slippery and has better grip. It is not used for lubricating the contact surfaces. So correct option is A, providing liners with better coefficient of friction. Next question. The function of surge tank in hydraulic power plant is. So surge tank, it is also called surge drums or surge pools. It is a reservoir that absorbs pressure spikes and provide water during pressure drops. So this is a diagram for surge tanks, hydroelectric power plants. This is a surge tank. Surge tank is vertical open tank just provided just upstream of the penstock. So here it is upstream of the penstock of the hydroelectric power plant. It is generally placed very close to the power station. It is placed just above the ground. The surge tank is placed near the powerhouse to reduce the length of penstock. So surge tank is an vertical open tank provided just upstream of the penstock of hydroelectric power plant. So it is placed near to the powerhouse to reduce the length of the penstock. Surge tank in hydroelectric power plant, it stores the water, reduces power fluctuations, and protect penstock from water hammering. So that is eliminates water hammer action and controls sudden pressure in the pipeline. So these are the various functions of surge tank. One is stores water, reduces power fluctuations, protect the penstock from water hammering, control sudden pressure in the pipeline. Four functions. Correct option is C. Reduce water hammer effect and breakage of penstock during sudden openings or sudden closure of valves. Correct option is C. Next question. The most hazardous among the nuclear power plants is most hazardous among the power plants of same rating is. So obviously the answer is nuclear power plants, because the major hazard of nuclear power generation is storage and disposal of spent and used fuels. Spent or used fuels. Improper nuclear waste storage and disposal results in environmental contamination. There is a risk of accidental leakage also. So one is storage problem and disposal of spent fuels problem, and third one is the risk of accidental leakage of nuclear radiation from the power plants. Correct option is D. Thermal power plants using biofuels, it is safe. Thermal plant using coal fuel, safe. Thermal plant using diesel fuel, it is also safe. This nuclear plant is most hazardous among the given four options. Next question. Two 230 volts 100 watt bulbs are connected in series. So these are 230 volt 100 watt bulbs are connected in series. Let I be the current flowing through the circuit. What will be the power consumption in each bulb? So we know that the relation between power, voltage and resistance is power P is equal to Vi, that is equal to V square by R. Now resistance R is V square by P, the resistance offered by the each bulb. So voltage is 230 volts whole square and the power wattage of each bulb is 100. So there are two resistors, resistance of each bulb. Let it be R1, let it be R2. So now R1 is V square by P, R1 is V square by P. Similarly, that is equal to R2. For bulb 2 also same rating it is given. Now total resistance RT is R1 plus R2, that is 2 into 230 whole square by 100. Therefore total power consumed PT is total power consumed. Total resistance is RT. PT is total power consumed by both the bulbs. Its value is V square by 2 R. So V square is 230 whole square by 2 So we can also write total power consumed is V square by total resistance RT. RT is 2R here, 2 into 230 whole square by 100. Its value is 50 watt. This is the total power consumed by both the bulbs. Now power consumed by each bulb. Power consumed in each bulb. It is 50 watt by 2, 25 watt. The power consumed by each bulb is 25 watt and total power consumption is 50 watt. Now as per the question, the correct option is D. Next question. An electric iron is rated at 2000 watt. It is on and off for equal durations. It is on and off for equal durations. So that means iron is on for 5 minutes and off for 5 minutes. While ironing, how long it will take to consume 1 unit of energy? So let us see the definition of 1 unit of energy. 1 unit of electricity is equal to 1 kilowatt hour. So that is amount of energy consumed by 1000-watt appliance in 1 hour. Energy consumed by a power source of 1 kilowatt in 1 hour. So given electric iron with rated power of 2000 and electric iron is on and off for equal time duration. So this electric iron will consume 1 watt if this is used in continuous manner. For continuous usage, for continuous usage, this 2000 watt electric iron can consume 1 kilowatt in 30 minutes. But here the condition given is it is on for equal duration, off for equal duration. So it will consume in 1 hour. It will consume 1 unit of energy in 1 hour. So how much time it will take to consume 1 unit of energy? So that is 1 hour. Option B is the correct. Next question. An inductor of 10 ohm reactance and capacitor of 10 ohm reactance at 50 Hz are connected in series with 10 ohm resistor. So the given is circuit is series RLC circuit whose resistance is 10 ohms and inductive reactance is also 10 ohms and capacitive reactance is 10 ohms. So for the circuit series RLC circuit, inductive reactance is equal to capacitive reactance. So this the value of inductive reactance is equal to capacitive reactance only at resonance. At resonance, the value of impedance Z is equal to resistance. So inductive reactance is 10 ohm and capacitive reactance is 10 ohm. And they ask to calculate the current will be. So current I is V by Z. Here the voltage is 300 volts and the value of Z is R minimum, that is 10. So the total current flowing in the circuit is 30 ampere. So option A is a correct one. Next question. Two resistors 12 ohm and 5 ohm are connected in series and the combination is connected in parallel to 10 ohm resistor. There are two resistors of 12 ohm. So two resistors of 12 ohm and two resistors of 5 ohm. So it is 5 ohm. Two resistors of 5 ohm are connected in parallel with the 10 ohm resistor. So this is a circuit diagram and this whole circuit is connected to 100 volts supply. Now let I be the total current flowing through the circuit. Here it is also I. The current splits here I1 and I2. So let it be IA. The splitting current is IA. Here the current is IB. Now the current IA is sum of IA plus IB by using KCL at this node. Okay. Now when resistors are connected in series, the total resistance is sum of all resistance. 12 plus 12, 24. 12 plus 12, 24. 5 plus 5 is 10. That is 34. 34 ohms parallel with 10 ohms. And the whole circuit is parallel with 100 volts. Now total resistance or equivalent resistance is R1 R2. So let it be R1 and this value is R2. So R1 R2 by R1 plus R2. R1, so that is 34 into 10 by 34 plus 10. Now current through resistor R2. So that is total current. Total current is V by R equivalent. So total current into opposite branch resistance by, so IR2 is IB, opposite branch resistance by total resistance. So that is R1 plus R2. So total current is V by V. V value is 100. V value is 100 by R equivalent. R equivalent is this value 34 into 10 by 34 plus 10. So 34 plus 10 is 44 into R1. R1 is 34 ohms and by total resistance. So 44. Its value is 10 ampere. Now the current flowing through this IR2 or IB current is 10 ampere. Now in the question, they ask to calculate the power consumed by the 10 ohm resistor. So power consumed by 10 ohm resistor is current flowing through 10 ohm resistor into R. Current square is current flowing through 10 ohm resistor is, that is IB current 10 ampere. So 10 square into 10, that is 1 kilowatt. 1 kilowatt is the power consumed by 10 ohm resistor. So correct option is C. Next question. This Buckhorse relay is used in the protection of transformers. So Buckhorse relay is a safety device that detects gas and oil flow changes in the oil filled transformers, also known as gas detector relay. This relay is used in the protection of transformers from faults occurring inside the transformer. So let us see some more points here. This Buckhorse relay detects faults inside the transformer due to winding or insulation failure, the faults due to cracked core, faults due to loose connections, and faults due to impulse breakdown of insulating oil or transformer oil. It acts as an interface between this relay acts as an interface between main tank and conservator tank of power transformer. This relay is a gas pressure operated relay installed in large power transformers and reactors containing the insulating oil. These are the points related to Buckhorse relay, and the correct answer is D. This relay is used in transformers. Next question. In a, if a single diode of bridge rectifier is open and the value of DC component for the input Vm sin omega t is, when a diode in bridge rectifier is open circuited, then output is similar to half wave rectifier. For half wave rectifier, output voltage VDC is Vm by pi. The average output voltage of half wave rectifier VDC is equal to Vm by pi. So let us see the bridge rectifier. Bridge rectifier consists of 4 diodes. So as per the question, let us assume diode D1 is open circuited. This diode is open circuited. For positive half cycle, D4 and D2. For positive half cycle, D4 and D2 are open circuited and D1 is already open circuited. So that means 3 diodes are open circuited and there is no signal flow through RL. For negative half cycle, D1 and D3 are reverse bias, that is open circuited, and D2, D4 are forward bias. So for negative half cycle, D4 and D2, these two are forward bias. Now current will flow like this. This is the flow of current through the load resistor. So that means negative half cycle exists at the output. So therefore, only negative half cycle is appearing at the output. This for a full wave input. In a bridge rectifier, when any one of the diode, either D1, D2, D3 or D4 is open circuited, only one diode is open circuited, then this bridge rectifier works like a half wave rectifier. So the correct answer is Vm by pi. What is the DC value of output is Vm by pi. Next question. Snubber circuit is used along with the relay for to avoid arcing. This snubber circuit is used to avoid arcing. So let us see the points related to snubber circuit. Snubber circuit is used with the relay to protect it from arcing, voltage spike and current transients. Snubber circuit is made up of resistor and capacitor connected in parallel with the silicon controlled rectifier or thyristor that suppresses the voltage spikes and transients that occur when switching. So this is RC combination. It is connected in parallel with the SCR or thyristor. Next, this snubber circuit protects relay from faulty ignition. Faulty ignition. This snubber circuit protect relay from arcing and fusing. Arcing and fusing. This snubber circuit protects relay from sp- spurious triggerings. Protects relay from damage and ensures reliable operation. And ensure reliable operation. This is the purpose of snubber circuit. So the correct option is C, arcing. Which of the following devices is a part of microcontroller chip? So microcontroller chip contains CPU, memory units, RAM and ROM, I/O ports with programmable pins, timers and counters, oscillators and clock circuits, interrupt circuitry, full duplex serial data transmitter and receiver, ADCs and DCs, DACs. So therefore microcircuit consists RAM, ROM, I/O ports. All of this is the answer. This microcontroller circuit consists all the above components given in the options. Correct option is D. Next question. So GSM uses the following multiple access methods. So global system for mobile communication uses both TDMA, that is time division multiplexing, multiple access, and FDMA, frequency division multiple access. So FDMA, this figure represents TDMA. Time is a division divided, here frequency is divided. So some more points is GSM is a digital cellular technology for voice and data transmission. It uses pi by 4 QPSK modulation. It operates either in 900 MHz or 1800 MHz frequency bands. So the correct option is combination of FDMA and TDMA. Next question. A standby UPS, uninterruptible power supply, is usually has a capacity less than 1 kilovolt ampere, 1 kVA, and can be used to power the critical components and systems for short time during the power outages. It is also called offline UPS or standby UPS or backup UPS, can supply power when AC main is fail. The correct option is power requirements of zero point 0.5 kVA. So it is not 5 kVA, it is less than 1 kVA, not 5 kVA, not 10 kVA, and not more than 10 kVA. So correct option is A. Next question. In a GNOT diode with high breakdown voltage, both P and sorry, in a GNOT diode with high breakdown voltage. So breakdown voltage is very high. So that means doping should be low. So in GNOT diode, doping and high voltage, doping and breakdown voltages are inversely proportional. So that is breakdown voltage of a GNOT diode decreases with increasing the doping concentration, or breakdown voltage of a GNOT diode increases with decreasing the doping concentration. So the correct answer is high breakdown voltage means very lightly doped. Both P and N are very lightly doped. Correct option is C. So let us see some points related to this. So GNOT diode is a heavily doped PN junction diode, and the degree of doping determines the reverse voltage at which GNOT breakdown occurs. So GNOT breakdown, increasing the doping level of a GNOT diode decreases the GNOT potential. The amount of doping in GNOT diode, it decides. The amount of doping decides. It controls the breakdown voltage, controls the location of GNOT region, increases the doping, increases the impurity, and decreases the GNOT potential. In GNOT diode, it is designed to operate in reverse bias, the direction of current opposite to that of arrow in the symbol, because GNOT diode conducts electricity in reverse direction. So this is a symbol, this is a arrow, current direction. symbol for the xenon diode, and the direction of current is opposite to that of arrow in the symbol, because in reverse bias the current will flow like this. Current will flow here, but it is opposite to the symbol mentioned on the diode. Okay. So in xenon diode, the doping and Zener breakdown are inversely proportional. So it is high breakdown voltage. So that means doping is very less. Both N and P regions are very lightly doped. Next question. Most of the holes present in the base of PNP transistor flow to the collector. Most of the holes present in the base of PNP transistor flow to the collector. In PNP transistor, most of the holes reaches to the collector. Or in PNP transistor, most of the hole will reaches to the collector, because PNP transistor holes are the majority carriers. In a transistor, emitter is heavily doped and moderate in size, base is very lightly doped and small in size, collector is moderately doped and large in size. When a negative voltage is applied to the base emitter junction, holes flow from emitter to base. Base is a thin region, so only small interaction occurs between electrons and holes can recombine. The electric field in the base collector junction pushes the holes from base to the collector. This results in large current flowing from emitter to collector. In PNP transistor, the entire current is majority current is due to hole current, and the current is controlled by small base current. So similarly for NPN transistor, most of the electrons present in base of NPN transistor will flow into collector. Electrons are injected from N-type emitter to base. Once electrons are injected from N-type emitter to base, already in base, it is rich in holes. Some of the injected electrons combined with holes. Majority of electrons in base crosses the base region and enters into the collector region. So correct option is enters into the collector. Next question. JFET configuration which connects high resistance signal source to low resistance load. Okay. So let us see analogy between BJT and JFET. So this is for common base, common emitter, and common collector. So base in BJT and FET, here base is gate and emitter is drain. Emitter is source, base emitter, collector is drain. So common base configuration or common gate configuration, common emitter configuration or common source configuration, common collector configuration or common drain configuration, both are same. So here in the question they have given common drain configuration, which has uh, high signal resistance and low source load. Signal resistance is high, input resistance is high, and output resistance is lower. So this is common collector configuration. So common collector configuration also called common drain configuration. Common drain configuration. In common collector, it is called emitter follower. Common drain configuration is also called source follower. This common drain configuration, voltage gain is less than or equal to 1, and it produces 0 degree phase shift. So common, we can written as common gate, common source, common drain. So this common source produce 180-degree phase shift, common drain produce 0 degree phase shift, common gate will produce 0 degree phase shift. Now common drain amplifier or source follower, input impedance is high, output impedance is low, voltage gain is less than or equal to 1, and current gain is high, and it provides 0 degree phase shift between input and output. Therefore, both common collector in BJT, common drain amplifiers in FET is used for impedance matching with high source to low resistance load, high resistance source to low resistance load. So correct option is A. Next question. When class B power amplifier is in quiescent state. So in class B power amplifier, the conduction angle of class A is 360, conduction angle of class B is 180, conduction angle in class AB power amplifier is 180 to 360, and in class C power amplifier, conduction angle is less than 180 degrees. So class B power amplifier, when it is in quiescent state, no current flows through the transistor in class B power amplifier, because transistors are biased to cut off. Here the transistors are biased to cut off, that is quiescent power dissipation is 0. The quiescent power in quiescent state, power dissipation is 0. The advantage of no current flowing through the transistor in quiescent state is that it increases the overall efficiency of class B amplifier. That is, the correct option is, when class B power amplifier is in quiescent state, no current flows into the no current flows through the transistor. In quiescent state, the power dissipation is 0. If no current is flowing means the power dissipation is 0. Correct option is C. Next question. Inductor filter used when? So inductor filter means, in inductor filter, large inductive reactance, that is large inductor, is connected in series with the load resistance to eliminate the AC component, because the nature of inductor is it blocks AC and allows DC. So for inductor filter, the formula for the ripple factor of inductor filter is pi by 2 root 2 into RL by omega naught L for half wave rectifier, that is for RL by 3 root 2 into omega naught L for full wave rectifier. So therefore, for both half wave and full wave rectifier, ripple factor is proportional to load resistance. So ripple should be low. So this ripple should be low means load resistance should be low. If load resistance is low, then load current should be high. To obtain smaller ripple factor, inductor filter must be used when load resistance is smaller, that is load current is larger. It is used for high load current. Load current is high, load resistance is low. Correct option is A. Similarly, for capacitor filter, this is a ripple factor pi by root 3 by 1 by omega naught RL into C for half wave, pi by 2 root 3 1 by omega naught RL into C. So the ripple factor in capacitor filter is inversely proportional to load resistance. Hence this capacitor is used for, it should be low. So that means RL should be high. This capacitor filter is used for high load resistance. Load resistance is high means load current is low. This is capacitor filter is used for high load resistance, or it will use for low load current applications. In LC filter, the formula for ripple factor is root 2 by 3 mod XL by XC. So LC filter ripple factor is independent of load. In LC filter, ripple factor gamma is independent of load. So these three are important. Inductor filter, ripple factor is directly proportional to load. In capacitor filter, ripple factor is inversely proportional to load. In LC filter, ripple factor is independent of load. So correct option is A here. So low load applications are high load current applications. Inductor filter. Next question. In a Wien bridge oscillator, if resistance in positive feedback circuit are decreased, then frequency. So the resistance at which, so what is the resonant frequency? Resonant frequency is the frequency at which oscillator produces maximum output is resonant frequency, that is bridge in balanced condition. So let us see the circuit diagram of this uh, Wien bridge oscillator. So in Wien bridge oscillator, the feedback circuit consists of series RC network in one arm, parallel RC network in adjoining arm. In the remaining two arms of the bridge, two resistors R1 and R2 are connected. So in feedback loop, series R1 C1 circuit is known as high pass filter. This series R1 C1, it is known as high pass filter, and series parallel R2 C2 circuit is known as low pass filter. And other two arms of Wien bridge consist of two more resistors, that is R3 and R4. Here op amp is used in non-inverting amplifier. The output voltage from op amp is fed back to both inverting and non-inverting terminals of op amp. This feedback network, this complete feedback network, it doesn't provide any phase shift. The total phase shift provided by this complete feedback network is 0. At resonant frequency, voltage applied to both inverting and non-inverting terminals are same. Therefore, next, the frequency of oscillation is 1 by 2 pi square root of R1 C1 R2 C2. So that means resonant frequency depends only on R1 C1 R2 and C2. If both resistance are decreased, if R1 is decreases and R2 are decreases, or both decreases, in that case resonant frequency increases as per the question. Okay. So for Wien bridge oscillator, the gain should be greater than or equal to 3, because feedback factor is 1 by 3. From this question, if R1 decreases or R2 decreases, or both R1 and R2 decreases, then resonant frequency increases, and resonant frequency is independent of R3 and R4. So correct option is C, increases. Next question. When the frequency of oscillation in crystal oscillator becomes parallel resonant frequency, then reactance of crystal oscillator will become infinity. So reactance of crystal oscillator will become infinity. So let us see the diagram for this reactance versus frequency. If frequency is greater than fs, so if frequency is greater than fs, so this is a frequency greater than fs, the nature of the curve is inductive. If frequency is less than fs, the nature of the curve is capacitive. If frequency is greater than fp, parallel resonant frequency, the nature of the curve is capacitive. In between these two, between fs and the frequency that exists between fs and fp, the nature of reactance is inductive. So series resonant frequency is omega s is equal to 1 by square root of LCS, and parallel resonant frequency omega p is 1 by square root of L into CSCP by CS plus CP. This is the equivalent circuit of quartz crystal CS, CP, LS and RS. Quartz crystal. Now it has two resonant frequencies, that is series resonant frequency and parallel resonant frequency. Radian per second. Units are radian per second. Now, when the frequency of oscillation of a crystal oscillator becomes parallel resonant frequency. So parallel resonant frequency. So this is the case, parallel resonant frequency. On both sides, inductive reactance approaches to infinity and capacitive reactance approaches to infinity. So simply the reactance will approaches to infinity. So this is the point. So here it will be the point. Correct option is A. Next question. The distortion in amplifier is found to be 3% when feedback ratio of negative feedback amplifier is 0.04. When feedback is removed, the distortion becomes 15%. In negative feedback amplifiers, the negative feedback in an amplifier decreases the distortion by a factor of 1 plus a beta times. So this is a known statement. So given distortion without feedback is 15%, distortion with feedback is 3%, and feedback factor is 0.04. Substitute the values in this expression. So df is distortion with feedback, d is distortion without feedback. So that is 3%, 0.03 by 15%, 0.15, 1 by a plus beta. So a into beta is 0.04. On calculation, we will get a value as 100. A value is 100. So this a is open loop gain. A is open loop gain. So open loop gain is 100, option D. Next question. The voltage gain of an amplifier without feedback is 60 dB. It decreases to 40 dB with feedback. Then what is the feedback factor? Given voltage gain of amplifier without feedback is 60, with the feedback is 40 dB. So we know that formula, voltage gain with feedback AF is equal to A by 1 plus A beta. A is open loop gain. So from this, beta is 1 by AF minus 1 by A. So that is 1 by 60, 1 by AF. AF is 1 by 40 minus 1 by 60. So that is 60 minus 40 by 60 into 40. 20 by 60 into 40. So its value is 0.00833. So correct option is B. Beta is this much. Next question. The switching power of PNP transistor is called. The switching power in a PNP transistor is called source current switching. Source current switching. The switching power with a PNP transistor is called source current switching, and this type of switching is used in negative grounded configurations. This type of switching is used in negative grounded configurations. The switching power with PNP transistor is called source current instead of source ground. With NPN transistor is called sinking current. So it is source current for PNP, sinking current for NPN. The term sinking refers to flow of current into the terminal. The term sourcing refers to flow of current current flowing out of the terminal. PNP transistor sometimes is called sourcing sensor because it is sources a positive power to the output. So correct option is C. For if it is NPN transistor, then it will be sinking. Sinking is for NPN. Sourcing is for PNP. Next question. The initial stages of RC coupled amplifier. So the initial stages of multi-stage amplifier we use RC coupling, resistor capacitor coupling, that is RC coupling, resistor capacitor coupling. Correct option is A. So multi-stage amplifier means the output of first stage is coupled to the input of next stage by using a coupling device. The process of joining two or more amplifiers using a coupling device is called cascading. So the total gain of multi-stage amplifier. So what is multi-stage amplifier? So it is the output of first stage is connected to the input of next stage using coupling device. The process of joining two amplifiers using a coupling device is called cascading. So in multi-stage amplifiers, the overall product total gain, the overall product of individual stage amplifiers is less than the product of individual gains. The total gain is less than the product of individual gains. It is due to loading effect in the next stages. The total gain in multi-stage amplifier is less than the product of gains of individual stages due to the loading effect in the next stage. The overall gain is not a product of individual separate stages since input resistance of second stage forms a voltage divider with the output resistance of first stage. So suppose this is the first stage and this is the second stage. So output resistance of first stage and input resistance of second stage. Between these two, some voltage divider network will be there. So because of that, loading effect will exist. Hence, overall voltage gain is not the product of individual gains. Overall voltage gain is less than the product of gains of individual stages because due to loading effect. So correct option is B. Next question. The oscillator that is mostly used for generating audio frequency signal is, so Wien bridge oscillator is most common oscillator used to generate audio frequency signals. So Wien bridge provides a wide range of frequencies. Correct option is A. Next question. Dash multivibrator is a square wave oscillator. So astable multivibrator. Astable multivibrator is also called square wave generator or free running oscillator, and it has no stable states. So both are astable states. Similarly, for monostable multivibrator, it is also called one shot multivibrator or a gating circuit or a univibrator. It has one stable state and one unstable state. So bistable multivibrator is also called flip flop or latch or scale of two toggle circuit or trigger circuit or reckless Jordan circuit, and this it is having two stable states. In the question it is square wave generator. Square wave generator is astable multivibrator. Correct option is B. Next question. In a bistable multivibrator circuit, the commutating capacitor is used. So in previous question we have seen the other names for bistable multivibrator is flip flop, latch, scale of two toggle circuit, trigger circuit, reckless Jordan circuit. It has two stable states, and the purpose of using commutating capacitors are speed up capacitors. This C1 and C2 are C1 and C1. These are commutating capacitors, and the purpose of these commutating capacitors are speed up capacitors. The other name is speed up capacitors. In a bistable multivibrator, is to speed up the response time, speed up the response time, thus reducing the transition time. Thus reducing the transition time. This commutating capacitor and multivibrator is also called speed up capacitor. When a triggering pulse is applied to change the bistable state from one state to other, it is necessary the transition period should be minimum, and it should require minimum but finite amount of energy. So correct option is C. To increase the speed of response, we are using commutating capacitor, speed up capacitor in bistable multivibrator. Next question. In a certain non-inverting amplifier, if input non-inverting operational amplifier input resistance Ri is 2 kilo ohm and feedback resistance is 100 kilo ohm and input resistance Ri is 2 kilo ohm, the closed loop voltage gain is. So closed loop voltage gain is given as 1 plus Rf by R1, 1 plus feedback resistance 100 by R1 2. So its value is 51. Correct option is C. So this is a non-inverting operational amplifier with input Vi given to positive terminal or non-inverting terminal. Output is V0 and feedback is given to inverting input terminal. Next question. In differential mode of op amp, the output voltage is equal to difference between the outputs of individual transistors. Its amplitude will be its amplitude will be twice twice the amplitude of signal voltage yielded at the collector to ground. So generally, this op amp emitter coupled the operation of emitter coupled differential amplifier has two operating modes, that is common mode and differential mode. So this is a common mode signal. This transistor provides 180-degree input signal, transistor provides 180-degree. Both signals are given. We are getting the zero output. Ideal case of common mode differential amplifier output is zero. Here it is zero. V naught is zero. In differential mode, two input signals V1 and V2 are of equal magnitude and opposite phases. Here, this is a input signal. This is one input signal. Here, this is a phase shifted signal. Here, it is a phase shifted signal, and this is the output signal. During the amplitude of output voltage will be twice the amplitude of voltage obtained either at either collector or ground. So correct option is A. During positive half cycle of V1, the input Q1 is positive sinusoidal and the input to Q2 is negative sinusoidal, thus achieved due to center tap transformer. On the collector Q1 and Q2, signals are 180-degree phase with respect to their input signals. The voltage is difference between the outputs of individual transistors. In common mode signal, the operation of input signal with same magnitude and same phase is applied to both transistors. A small output voltage is produced at the output and the common mode gain is very low. So correct option is twice. So this is a differential mode operation. This is a circuit diagram for differential mode and this is common mode. Okay. So correct option is twice. In differential mode of op amp, if output voltage is equal to difference between the outputs of individual transistors, its amplitude will be twice the amplitude of signal voltage yielded at the collector to ground. Next question. Common mode voltage gain of operational amplifier. The common mode voltage gain of operational amplifier is very low. Ideally, it is 0. When both inputs of op amp are at same voltage, the output voltage is 0. So these are the characteristics of operational amplifier. Input impedance is very high. Ideally, it is infinity. Output impedance is very low. Ideally, it is 0. Voltage gain is very high. Ideally, infinity. Common mode voltage gain, it is very low. Ideally, 0. When both inputs are of same voltage, that is 0 offset voltage. Output can change instantaneously. That is infinite slow rate. Ideal case. The main purpose of bias circuit to achieve the ideal behavior of op amp is high CMMR. So in operational amplifier, input resistance should be infinity. Output resistance should be 0. Voltage gain is infinity. Common mode voltage gain is 0. Slew rate should be infinity and high CMRR, common mode rejection ratio, high differential gain, and high input impedance. These are the practical cases. Ideal cases are infinities and zeros. Next question. A 741 op amp with a gain bandwidth product of 2 megahertz. So bandwidth product means of an operational amplifier is figure of merit that measures how op amp gain and bandwidth relates. It is defined as the product of open loop voltage gain and the frequency at which it is measured. So that is gain bandwidth product. The gain bandwidth product is 2 megahertz and voltage gain is 40 dB. So voltage gain is 40 dB means this 20 log some gain is equal to 40 dB. Now gain is 100. So given gain bandwidth product is gain into bandwidth is 2 into 10 power 6. So gain is 100. We need to calculate the bandwidth. So its value is 2 into 10 power 6. Now bandwidth is 2 into 10 power 4, 20 kilohertz. That is 20 kilohertz. Correct option is B. Next question. Which part of the characteristic curve of a diode is useful for log amplifiers? The log region between 0 volts and 0.7 volts on a diode characteristic curve is useful for log amplifier because the voltage diode is proportional to the because the voltage across the diode is proportional to the log of the current through it, logarithm of the current through passing through it. So logarithm amplifier or log amplifier is an electronic circuit that produces output is proportional to the logarithm of input. So this is a circuit diagram for log amplifier and output voltage expression. So the correct answer is C, the log region between 0 and 0.7 volts. So this is part 1 for 50 questions.